Hello, everyone. Welcome to our talk. Thank you very much for joining. Today, we're together to discuss why it's time to develop apps for Android cars. I need the remote. And to do so, we are going to answer a few questions, such as what is an Android car and what is Android Automotive? Why now is the time to develop apps? How to do it with some high-level concepts. What are the challenges that, as an app developer, you could face, and what we're doing to actually solve these challenges. And we'll finish with a live coding demo of how to implement push notifications in cars. But before, we need to introduce ourselves. So we are part of COVESA. We are part of the COVESA Automotive AOSP group, which is a group that gathers together car manufacturers, technology companies, and app developers to work on how to standardize Android Automotive and how to make it easier for app developers to build apps for Android Automotive. I'm Gabriel. I'm part of Happening by Forvia, and we are developing a white-label app store for Android Automotive.
Hi, everyone. Excited to be here. I'm Sabine. I'm working for BMW, and I'm a co-chair of the AOSP group at COVESA.
Hi. And I'm Chris Simmonds, and I self-identify as a professional geek.
So first, what is Android Automotive? What we call AAOS. So Android Automotive is an embedded infotainment system for cars, which means that it runs directly in the car, and it positions itself in an ecosystem where you will also find standard Android, QNX, Linux, automotive-grade Linux. And something that is a bit misleading is that Android Automotive is different from Android Auto. So Android Auto, like CarPlay, is actually a phone mirroring solution, which means that apps run on the smartphone that is sending a video stream to the car. And actually, it's important to note that Android Automotive is currently the fastest growing infotainment system for cars. So infotainment, it stands for information about the vehicle and entertainment for the passengers. So basically, it's what you find on your car screen. So if we look at the history of Android Automotive, it was announced in 2017 by Google, and in 2019, the first car was shipped with Android Automotive. It was the Polestar 2, which is Polestar is the sister company of Volvo that is now focusing on building electric vehicles. And now, almost all major car brands are shipping cars with Android Automotive. So there is a prediction from 2022 that says by 2028, 70% of new cars will be shipped with Android Automotive. And we believe that this is becoming a reality. Just as a side note, every year, globally, there are 100 million cars that are produced across the world. So quite a large market. How does it look like in practice? Just a few examples here. Top center, it's a Renault. Top right, it's a BMW with a gaming experience, a Mini, a Mercedes-Benz, and a Lotus, and they are all running Android Automotive. But what is important to know is that when we are talking of Android Automotive, there are actually two main flavors for Android Automotive. There is the AOSP flavor, pure AOSP, and there is the GAS flavor. So GAS, it stands for Google Automotive Services. So when they install Android Automotive in cars, car manufacturers, they can go for either one or the other option. If they decide to go with the Google Automotive Services, they get a bundle of apps that include Google Maps for navigation, the Play Store for the App Store, and the Google Assistant that is being replaced by Gemini for the voice assistant. If they go with the AOSP route, they cherry-pick their partners for each of these apps. So for example, for navigation, some leaders are here, Mapbox and TomTom. For the app stores, you have Happening by Forvia and Harman ReadyLink. And for the voice assistant, you have Alexa and Simmonds. These are just a few examples. And if you're wondering, OK, but how is the market like? What percentage of cars are running the Google Automotive Services, and what percentage of cars are going the AOSP route? It's hard to have percentage, but we can share some which brand is actually using which solution. That's what you're seeing on this slide. And so you can consider that as of today, the market is like equally divided between the two solutions. So what's great is because you have Android Automotive in cars and you have app stores in cars, that means that you can ship your apps, you can develop and ship apps to cars. So in the past, it was a bit painful because app developers had to discuss with each OEM independently, but now that you have app stores, it's getting structured. So you just need to upload your app to the web portals of the app stores, and it gets distributed to all the cars. Just a few examples of apps that are already in the ecosystem. That's not exhaustive. Within Appling, in our catalog, we have approximately 400 apps, which is still quite a small number. If you think that in a few years, we'll have dozens of millions or hundreds of millions of cars running Android Automotive and still a small number of apps. And that's why we believe now is a good time to actually join the ecosystem and ship your app to cars. And now, Chris is going to give us some concept about how to actually build apps for cars.
OK, so it's my job then to give an overview of how you develop apps for cars. And first of all, we need to say that when you're developing apps for automotive, automotive is a different environment to phones and tablets. There are certain things that you must consider. The driver distraction is being the key one. So the driver must be able to use your user interface whilst driving without crashing the car. So this means that large icons, great big icons that you can easily push on a touchscreen. Short listen menus. We don't have time to glare at the screen. You have to just glance, move on. No distracting animations, videos. This is very important, and so there are a set of templates provided that will keep you within the correct bounds. And there's a quote there on the screen from the training pages, and I think it appears different places as well. Google takes driver distraction very seriously. Your app must belong to one of the supported categories and meet specific design requirements before it can be listed on Google Play or any other app store for that matter. So really, I want to talk a little bit about templates and just give you a quick overview as to what they look like. So currently, there are seven templates. Navigation, points of interest, fairly obvious. IoT, this allows you to interact with your smart home from your car, so you can turn the heating on as you get close to home or something. Weather, media. Media in this case really means audio, not video. You can't watch video whilst driving, obviously. So this is streaming media sites, internet radio, that kind of thing. Messaging, so this is, again, for the driver distraction case, this means displaying short text messages on the screen or converting them to speech using text-to-speech or something of that sort. And I've got screenshots of 4 of those categories. And you can get this gives you an idea of what they typically look like. They all look kind of similar because they're all using the same a similar set of templates. But for example, if you look at the top left, the messaging app, that's a good example. You can see great big icons, menu with like 5 items in it. That's the typical way things look. So how do you create an app for this environment? So this diagram is showing really the stages that you go through from your application to the car. So your car app talks to the car app library. So this is part of the Jetpack, it's part of the SDK. The car app library talks to a system app called the app host. So the system app is provided by the OEM, and it's responsible for taking the instructions from your app and then interpreting them and rendering them on the host operating system. So it looks a little bit like this. So this is your Android manifest. And here we first of all, here we set up an intent filter so that the car app service can call our app. And we also specify the category we're going to implement. In this case, I've chosen, for no particularly good reason, POI, points of interest. OK, so this is the kind of introduction, the inroads into your app. Then you need to implement a car app service. This is the entry point into your app. And at this point, you need to create one or more sessions. So a session is an instance of your app. You can have multiple instances of your app. For example, you may have one instance running on or displaying information on the console, and maybe another one displaying information on the cluster display. The session will create one or more screens. So the screen is the object which is going to allow you to display stuff and interact with the user. And the screen object is going to do that through something called a template. So the template then allows you to lay things out on the actual physical display using lists and grids and other useful things. OK, so that's as deep as I'm going to go into that at the moment. I'll give you some references in a couple of slides' time. But I want to talk a little bit about the app host and also something called the API level. So there is a separate API level for cars called Car App API level. Currently, there are 8 levels defined, as shown on the screen. And these are implemented, first of all, in the Car App library, the CAL. The Car App library has its own version numbers, currently at version 1.7. That shows you which Car App library version supports which minimum API level. But this is also affects the Car App host, because the Car App host is a separate component provided by the OEM, and that will implement a certain minimum API level. And this is how you define in your manifest what the minimum API level your app is going to need. OK, so if you want to go on and do this stuff, there's a bunch of useful information there. I picked out 3 sources of resources here. There is a use the Android for Cars app library, top one. There's a nice little code lab which goes through a practical implementation of this stuff step by step. Is the second one. And then the bottom one, which I actually found most useful, is that at that GitHub, there's a whole bunch of sample code. So you can kind of see how things work for the different categories or different templates. And yeah, copy and paste. OK, I want to come back to the one final thing there and talk about the app host, or car app template host, to give it its full title. So this is interesting. Like I say, it's provided by the OEM, and it's the bottom layer, or it's the intermediate layer, actually, between the car app library and the operating system. So this is a little bit convoluted, the way this works. When this was first announced, there was an open, or there is an open source version of this, part of AOSP. But it kind of got stuck at API level 4. So if you want to use pure open source, you can only support API levels up to 4. If you are licensing GAS, then there is a version of the app host which supports all levels. If you're not supporting GAS, so you've got to do it yourself, either you go with the open source version from AOSP, or what really happens is that most people take the open source version and they kind of hack it around a little bit to add in missing functionality. This is a pain because it leads to duplicated effort, inconsistent results, and so on. So one of the things we're doing at COVESA is to try and standardize this so that there is a reference app host, which hopefully all the OEMs will be using. And then finally, in this section, workshop, exclamation mark. So if you want to try this out for real, come along this afternoon to Building and Shipping Android Automotive Apps. Nuno Palmer, Florian Hirschman, and Stefan Postulaci. I'm not sure if I got that name correct. But in Jetpack Junction, this room, later on this afternoon. And I think you get to try it out on the Mini outside, am I right? Yep, so you get to make things work on that nice little circular display on the Mini. OK, and that's me done for the moment. Head over to Sabine. Oh, thank you.
Thank you, Chris. Now we have an automotive OS market. The market is there. There are templates. So where is the problem? If we look under the hood, we will find that there is fragmentation ahead. The app developers would need transparency on the reach they would have if they develop an app on available car brands and models. They would need to know how to test it, emulators, test cars. And on the other hand side, the app developer will face fragmentation because there are many OEMs out. And this means many Android versions, different app host versions, as we've just heard, different possibilities when vehicle properties are concerned. In the end, that would mean that an app developer would need to develop an app per OEM. And that's where COVESA comes in. Our platform ecosystem approach means that we have a standard, a COVESA standard, and that we have a store provider who would then deal with all the OEMs and who would take the standard, and the app developer then could develop the app once and deploy it to many OEMs. How do we address fragmentation at COVESA AOSP? On the one hand side, we smoothen fragmentation by offering push notifications for AAOS cars. This is ready. You will see a demo soon in this talk. Then we work on Automotive AOSP app host upgrade to EG render maps. We work on a dynamic access control for vehicle properties, reducing access barriers for video content providers. And there is still more to come. We have a lot of topics in our backlog concerning onboarding, location-based services, payment, and so on. And then in order to make it easier to test, we are working on an AOSP emulator project, which would be taking the AOSP emulator and be enriched with the COVESA capabilities. Picking out two of the most important topics to us. As we have heard, the AOSP app host is outdated when compared to the GAS app host, and this creates fragmentation and efforts for app developers. So what we propose is that there should be an updated AOSP host, and that we would recommend then for the OEMs to implement this updated OEM AOSP host to reduce the fragmentation that is already out there. You see some examples of templates that are not available in AOSP, most prominent being the maps. If you want to display maps and using the API level 4, you will just see text instead of a map. Coming to talk about vehicle properties. Now here we have a problem that there is a missing transparency on the properties that are available at each OEM, that there are a lot of privileged properties which need an OEM signature, which makes it one app per OEM again. And for the OEM, that there is no granular dynamic access control. There's no way for an OEM to set free all the properties that are out there. There needs to be a possibility to control that. And we at COVESA propose that we develop an open source module which offers this dynamic access control without an OEM signature. And we are about to prepare a proof of concept for that, and we'll work on that. In the end, what vehicle data access needs is for the OEM and dynamic access control, and for the app developer, a cross-OEM standard API. Now, all these topics and more we are discussing in our meetings, the most prominent being on Mondays. In our expert group, there are apps and content providers there are store providers, tier ones, OEMs, a lot of people, a lot of companies. And I would like to welcome you to these meetings. Join us, bring your problems, bring your ideas, and contact us. And on this page, you will also find the slides. Thank you.
Okay, so me again. So I just want to give a demo, a live demo of one of the things we've been working on at COVESA, push notifications. So this is important because there isn't really a good standard for push notifications within automotive. But you can't write an app which is running in the background the whole time and polling or keeping a socket open or something. Eventually you'll get killed. So this is a mechanism which gets around that. So first of all, push notifications. What do you need to make a push notification service? So 4 things it says. Can't see that from here. Let's go over here. Right, so over here we have your app, a third-party app of some kind. And it wants to send a push notification, so it communicates with a it communicates with the application server. It's then going to send a push notification to a push server. Okay, so app to push server, HTTP post, pretty simple. The push server is then going to send it to whichever device it's registered against, and it will send a message to a distributor app. So the distributor app is running on the device in the car, and it will then forward the notification on to the associated app, typically using an intent or something like that. So the distributor app and your third-party app are running on the same machine. The push server is running remotely, and the application server also is running remotely. So there's a good solution to this pre-existing called Unified Push. And at COVESA, we've basically funded some additional development to the Unified Push project to make it suitable for kind of use in a challenging environment, including automotive. So part of the stuff that we did or funded Unified Push to do was to implement these various RFCs, RFC 8030, 8291, 8292, which implement the various things on the list there. So time to live, urgency, collapse messages. Possibly the most important thing really is VAPID, server identity, so we can make sure that your messages can't be spoofed, and encryption, which makes sure that your messages can't be eavesdropped. So now we have Unified Push version 3. You can go find all this stuff, by the way, if you go to unifiedpush.org, I think it is. That is the core project. So we are simply leveraging existing code, open source code, and incorporating that into the automotive solution. So simple to use, to do OEMs. So if you are the OEM, basically you need to write your own version of the distributor app based on some sample code, which I'll look at in a moment. And if you are the app developer, then you need to include the Unified Push APIs into your app. They're not complicated. The whole thing, by the way, I should have said this earlier, the whole thing's based, or Unified Push is based on a thing called Web Push. So Web Push has been around for some years. It's built into every browser. It's in Firefox, it's in Chrome, it's in whatever browser you use. So this is a well-established standard. So there is a reference distributor app called SunUp, which you can install from various places as shown there. It's open source, so typically you would take the source code for this and use this as the basis of your custom distributor app. There is a reference push server. So the push server is running remotely on your cloud somewhere, or whatever. The reference is called auto-push-rs because it's written in Rust. And it is, the project is run and hosted by Mozilla, and it is in fact the web push that you use if you're using Firefox. So the COVESA Unified Push implementation works with this server. The server itself is open source. You take a copy of this and modify it if you want to create your own and host your own instances. And then there's a sample app called Unified Push Example. So you could use this to see how to integrate Unified Push into your apps. And demo time. So this is where it all goes wrong. It's okay. There we go. So this is my emulator running here. So it's just the standard automotive emulator that you get with Android Studio. And I've lost my mouse. There it is. It's gone to sleep, and it's sort of... OK, right. So list of apps. I thought I had installed it, but I didn't. But I can install it now. So I have a little script which does this, because I have scripts for everything. So this is just side-loading the APKs. So now we have SunUp, which is the distributor, and the example. So I'm just going to launch SunUp. Yeah, apologize. My laptop is not the fastest laptop in the entire world, so it's going a little bit slowly. And also, that should have done something differently. Let's try again. OK, requires permissions, yes. Allow. OK, so that's the distributor app. This would start, I mean, you'd only need to do this once. This will be auto-loaded every time you boot up. Then we go to the example. Again, it needs permissions. Send you notifications, yes. OK. It's not actually registered with the distributor app, so I'm going to click on the register button here. And yeah. So now it's, you can see it's registered. There is, across the top there is the endpoint. So that's the push server that I'm going to communicate with. And you can hopefully see that it is the Mozilla.com push server. And there's an authentication token to authenticate that the sender and receiver of the message is valid. And if I go back to SunUp app, yeah, you can now see it has a registered application. So you just have one distributor. You could have multiple apps using that same distributor app. And then demonstration, there's a little button here I can press which says send notification. And you may not have noticed, but the notification has arrived, a little red dot there against the bell icon. Click on that. UP example, web push test. OK. So yeah, I can do that again. So I send a few more notifications. Yeah, we have some more notifications. What we can also do, and this is a little bit more fun, I just clear those down. And here. OK, you may notice at the bottom here, it says there's a test page. So I click on that link. And it gives me a QR code. And this will allow me basically to send a push notification from my phone. So I should just do this. Whoops. Click on the button. It says test web push. Hopefully I get in there before you guys. Send request. OK, so I just typed hello. Hopefully when I press this. Yeah, OK. OK. OK, go for it then. So everybody can send messages. So this is cool. So this is a good example of unified push in action. You guys are pushing notifications from your various phones via the Mozilla server to my emulation here. So this is cool. Yep. Thank you. So I think there's one more slide still to go. Sorry, I'm going to have to stop you fun here. Yeah, so I think we've had these QR codes before, but this is just to remind you that COVESA, we do a bunch of interesting stuff here. Please join the meetings. You don't have to pay money. You don't have to be a member to contribute. And I think everybody in this room will be welcomed there. And yeah, COVESA, the whole framework standardization group is to make life easier for OEMs and for developers writing automotive apps. Yeah. And I think we're basically done.